Yes, Vasvi, am I audible to you?
Yes, ma'am.
All right. So, as I told you, there is one question that is very important from this topic, TIR. So, I want to discuss that, okay? Because it's a very, very common question that repeats itself in almost all the papers, okay? So, I'll discuss this question and then only I'll move to this lens and spherical refracting surfaces part. This is a point source of light S is placed at the bottom of a vessel containing a liquid of refractive index 5 by 3. So, this is a liquid and this is the source. Here, X is the source. A person is viewing the source from the above surface. Okay, from the top
Okay,
surface, the
ma'am.
person is viewing like this from here. So, what happens? There is an opaque disc of radius 1 centimeter floating above. See, this is the disc whose radius, let's say, is r, because values you can put later. I want to teach you this question first. So, floating above the surface, center O of the disk lies vertically above the source. Here is your source, here is the center of the disk. It's like there is a disk above, here a source is there. When you join both of them, they'll form a straight line like this. Okay?
Okay, ma'am.
And then it says the liquid from the vessel is gradually drained out through a tap. What is the maximum height of the liquid for which the source cannot be seen at all? Basically, when is that possible? See, when it cannot be seen means if this is the light ray, let's say this is the incident ray, this is the source. Let me explain you this first. Understand it here because that diagram I'll use for the calculation. There is a disk above and here is a source. They are connected like this. Okay. Since it's a
Okay, ma'am.
source will give its light rays on both the sides of the disk,
Yes, ma'am.
and this is filled completely with water or whatever.
Mm.
Okay. Now see, if the light rays they bend and come out like this. So for here, it will be very easily observable, correct?
Yes, ma'am. Yes, ma'am.
But what the question says, it is for which it cannot be seen at all. Means manage this somehow that this light doesn't come out. So the possibility is that if this grazes over the surface, then nobody will be able to see it. So that's why when you drop the figure of the whole, the figure is looking like what I have shown to you. This one. This is basically the TIR. Before TIR, this is the critical angle that has occurred. And so here the angle of refraction is 90 degree. Now have you got why is this grazing like this and an arrow is made instead of getting refracted over the other surface?
Yes, ma'am.
Okay then. See, how to solve this question is this clearly shows that this is critical angle. I just draw this triangle separately. See, this is the height h, this is the radius r, and this is the critical angle that is IC. Okay, this is our
Mm.
critical angle which is IC. This side will be, this is the perpendicular hypotenuse. So r square plus h square, that is the hypotenuse. So this gives us, this is the perpendicular, this is the base, this is the hypotenuse. Now
Mm.
look, from here we know one thing already. According to Snell's law, what is the formula value of sine IC? Snell's law for critical angle.
Sin IC will be 1.
Why?
No, Sin IC. Sin IC is equal. Sin IC by sin R is equal to N2 by N1.
Again, you're okay. Tell me the values where everything is there in front of you.
Um. Will sin R be 1? Either one should be 1, right?
Sine R will be 1, you're right?
Yeah.
Because
Sin R
it's
will be
90
1.
degree.
So
So sine I
N2
by sine R, yes.
N2 will be. Um, Ma'am, do you use N2 by N1? But then N2 and N1, the values are not
That's why I
same.
told you don't remember it as N1 by N2. And I think this is the fifth time I'm correcting you for this.
Yes,
In the
ma'am.
past two classes also you have been just using N2 by NR. What did I tell you? How to use Snell's law so that you don't get stuck in.
Ma'am,
Let's say the
I
refractive index is n. Now tell.
it will be sine it will be n into sine IC
Hmm?
is equal to air is also 1, so 1.
1 into?
1.
So what is it? It's so difficult. See, you're right. Use this, Rasmi. See, I also will always want you to remember the formula. But in this, you will get stuck. Even I get confused because is it ND by NR, NR by ND, 1 by NDR means NR by ND and all. Use this
Yes.
way. Eventually, it's the same thing.
Hmm.
Okay, so you write this or not directly, you can then say sine IC is 1 by N basically.
Hmm.
Correct. This is correct. If you're able to write, in fact, I'll write sine 90-degree only so that you can write it. That is one point. Okay. Now from this triangle also we can calculate sine IC. Using this
Yes,
triangle,
ma'am.
we can calculate sine IC. Tell me. In triangle, let's name it something. SOA. Huh? In triangle SOA. SOA, huh?
Sine IC will be equal to um it will be base h by root of r square plus h square.
What?
Ma'am, sine
Sine.
IC
What is sine theta?
sine theta is h by root of r square plus h square.
Heads? What heads, Vasme?
It's r.
Sine.
No, ma'am, it's r. It's r.
It's R.
Yeah, it's r.
That's the height.
Yes, ma'am. It's r.
Perpendicular by hypotenuse. Okay.
Yes, ma'am.
This the same formula. This is R by under root of R square plus H
H
square.
square.
Both of them are the same thing. Sin IC, sin
Yes.
IC. So we can equate 1 by N is equal to R by under root of R square plus H square both the side. 1 by N square will be equal to R square by R square plus H square. We can cross multiply. R square plus H square is equal to N square R square. So
Yes,
from
ma'am.
here, if we shift this, uh, R square minus N, no, we'll shift that. H square will be N square R square minus R square. Yeah, now it's right. H square will be R square N square minus 1. Take the roots. H is equal to R under root N square minus 1. Yes,
Yes, ma'am.
that's the height. A very, very important question that repeats. Now see, its value and radius value are given to you. Radius in this question was 1 centimeter and this was 5 by 3. You can solve that. Okay, but these steps will be very common in this. All right.
Okay, ma'am.
Write it, then let's start the new topic.
Okay, ma'am. Can you read the third last sentence of the question?
What does mean?
Can you read the third last sentence of the question? Liquid from the vessel is gradually.
Gradually drained out
Oh, brain.
through a tap.
Okay, ma'am. Ma'am, I wanted to ask you something. Yesterday, I wrote the revision test for the fourth chapter, and there was a question where the numbers were not clear.
Yes, yes, I heard it. Some symbols were dollar and tick,
Yes,
4 volt,
ma'am.
2 volt. No, yeah, I didn't make the paper actually, so that's why I didn't know the values also. So they even asked me for the values. I did not make that paper. That wasn't made by me. That's why I didn't even know the values. You can leave. You will be given grace mark for it. Don't worry.
And done, ma'am. Can you scroll up? Ma'am, can you scroll down? Ma'am, can you scroll down? Now I'm done.
Okay, now talking about spherical refracting surfaces. Spherical refracting surface means, see, you have a glass piece, okay? And in this glass piece, you just cut a portion. Now, we discussed that that portion, if we paint it from one side, that becomes a mirror. What if we
Yes,
don't
ma'am.
paint it? So that glass surface, that is what we are going to study. Spherical refracting surfaces means the glass surfaces. Okay. So this is your sphere. The center of curvature is complete is the radius of curvature. You cut a portion like this. Now see, this will be the denser part because this is the part where the glass is present. And this is the part where air is there. So denser is the glass one, air is of course rarer than your glass. So this is known as a convex surface. Why? Because the air this is available no, for the light rays to enter air part
Yes, ma'am.
in the air. Similarly, if we take the opposite means, denser is outside, rarer one is here. Means I cut it in a manner. What if I cut it like this? Means this part is present. Are you getting it? So what will
Yes,
happen?
ma'am.
The rarer part is now involved. Now this is your air, while this will be the glass. Yes, what will happen? The concave surface is available. The concavity, wherever you see this curve is present, that is your concave surface. Okay.
Okay, ma'am.
Now we basically see two things here. Initial velocity, I'm saying initial velocity, the image distance, the object distance, the radius of curvature, and both the refractive indices. Both the refractive indices means of the denser and the rarer. We see a relation among that. So see, how can refraction occur even if I give you this one concave surface? It can happen if
Yes,
the light
ma'am.
ray comes from the denser and goes to the rarer. It can come that it will come from the rarer to the denser like this.
Hmm.
So refraction will occur from rarer to denser. Okay, means when I say rarer to denser, that means your object is present in the rarer surface and the image is formed in the denser surface. While for denser to rarer, the object is formed in the denser and not formed is present, and in the rarer part you have the image formed. And both the cases are there for convex concave mirror, and this one also for concave convex mirror. Basically you have two mirrors, not mirrors, surfaces, convex and concave, rarer to denser, denser to rarer. Similarly this one, denser to rarer, rarer to denser, like this. Okay.
Hmm. Yes, ma'am.
Now first says refraction from rarer to denser medium. So rarer, this is object is present in the rarer medium, and this is the denser medium, means this will be the glass. Okay. So let's say this is the refractive index N1 here of the rarer and N2 of the denser. Okay.
Yes, ma'am.
So object is present on the rarer side. Now the light rays come. This is your spherically refracting surface. This part.
Hmm.
This is the spherical refracting surface. So object strikes the light. Now, what happens whenever an incident ray falls on? Refraction will occur, correct?
Yes, ma'am.
At this surface, this normal has been drawn. And I told you, if you remember, for any curved surfaces like mirrors and all, you join the center of curvature with the point that gives you the normal. Remember, I told you
Yes, ma'am.
for any normal reaction, if you have center of curvature, this is the mirror, just join the line. This will give you the perpendicular, that is the normal. Fine. So here as well, this is the normal. So this light ray gets bent and an image is formed over here. Okay.
Hmm.
Now, when the point may not exactly lie on the pole because of the curvature, this can lie over here. So we just take a portion like this, which we mark as some point N or anything. So this is the line that is just drawn, which is very close to P. See, problem is that why am I drawing this perpendicular? Reason is that if I don't draw it, and let's imagine this MN is not there, what do you get? MP, this. This is not forming a triangle. For
Yes,
triangle, you
ma'am.
should get a straight line. And without triangles, you cannot derive this. So that's why for the usage of triangles, this has been dropped. And this is present in so proximity, P and N are so placed so close to each other that whatever values you will get for M, and that will actually be for MP. Why am I focusing on pole? Because everything has to be taken with reference to the pole. So you can equate it. N can almost be written as P. Okay?
Okay, ma'am. Okay, ma'am.
Alright. Now see, object and the pole. This distance will be object distance U. Pole and the image. This distance will be V. Okay? Center
Hmm.
of curvature to the pole of the mirror, that is R. Fine. Now, normal
Yes, ma'am.
reaction and the incident rate, they will make the angle of incidence.
Yes, ma'am.
And this normal reaction with this refracted ray, this will make the angle of refraction.
Yes, ma'am.
Okay, now this angle is just put as alpha, this angle is put as beta, and this is given as gamma. Just
Hmm.
random values we have taken because these angles will be needed in order to derive the formula. If we
Yes,
talk
ma'am.
about this, okay. Now at this point M, if we apply the Snell's law, now you apply and tell me the Snell's law at this point M. What have we discussed before?
Um, Sine I into N1
Yes, N1 into sin I, correct?
is equal to sine N2 into sine R.
Very good. Now you've understood this.
Yes, ma'am.
Very good. Now see, the angles are actually very less here. You can see the deviation. It's so close. So we are
Hmm.
going to apply the small angle approximation. For small angle approximation, basically you have some conditions like angle should not be very much greater. Means it should be almost less than or equal to 15 degrees, like 7 degree, 3 degree and all. Okay. So these angles are very less for surfaces because it's just a part of the surface. It's not a mirror or it's not a lens.
Yes,
So
ma'am.
you can almost write sine theta as theta. Okay, whenever you use the small angle
Hmm.
approximation, sine theta can also be written almost as theta. So sine I can be written as I, sine R can be written as R. So I can make this
Okay, ma'am.
equation as N1 into I is equal to N2 into R after approximation. Am I clear?
Yes, ma'am.
Okay. Now look, this from here O, this is M, okay, and this is C. Actually, this will be O M N C O M C C. In this triangle, if you look, I'll just highlight it. O M T. Got this triangle?
Yes, ma'am.
Now, in this, can you tell me, is there any exterior angle?
Mm. Yeah,
I. And do you remember there's a property and you already have math, so I hope you
yes,
must be
ma'am.
thinking. Which one?
Alpha plus R is equal to I.
Not R.
Oh, sorry,
Gamma.
gamma. Alpha
Yes,
plus gamma
yes.
is equal to I.
Opposite angles are equal to means the sum of opposite angles of a triangle are equal to its exterior angle.
Yes,
Exterior
ma'am.
angle property? Yes, absolutely right. Alpha plus gamma is equal to I. Okay.
Yes, ma'am.
Now see in this M, C and this one. M, C, I. Can you see this triangle? The smaller one? Can you notice here is an exterior angle too,
Yeah, gamma,
which is equal to?
which is equal to uh, R plus beta.
Correct. R plus beta. So we can say R plus beta is equal to gamma. So from here I can say R is equal to gamma minus beta.
Yes, ma'am.
Now let me put in the values here. I have gotten the values. So it will be N1 into what is I? Alpha plus gamma is
Yes,
equal
ma'am.
to N2. This will be gamma minus beta. Fine.
Yes, ma'am.
Now we have to write the values of alpha, gamma and all. If I take this triangle OMN, this one,
Hmm.
this triangle, that's why we have drawn the 7 perpendicular. In triangle OMN, what will be tan alpha? If you tell me.
Tan alpha will be Mn by Mo.
Correct. I can say tan alpha will be Mn by No. Now see, these are all small angles. Like sine theta is approximately equal to theta, tan theta is also approximately equal to theta. Right?
Hmm. Yes, ma'am.
So tan alpha is equal to mn by on, which is equal to alpha. Okay, or I'll write it like this. Tan alpha is almost equal to alpha, which is equal to mn by on. Fine.
Yes, ma'am.
Okay. From this triangle, MNI, this one. Tell me tan beta.
Tan beta will be,
Yes, tan beta will be from here.
ma'am, can you show the triangle again?
MNI. MNI for beta.
MNI. It will be MN by MI.
Correct. So see, tan beta will be almost equal to beta, that is mn by ni. Okay. Similarly, I think the best method, because we need a common side, so everything can be cancelled. Now, can you see mn is coming everywhere in this
Yes,
triangle
ma'am.
also, in this also. So we'll take this small triangle, this one.
Hmm.
Here, can you tell me what is the value of gamma?
MC by NC.
M?
MC by NC.
NC by?
Ma'am, MC by NC. Right?
Tan alpha, tan beta, gamma.
NC by MC.
This is the triangle
Hmm.
MNC. In triangle
Yes, ma'am.
MNC. What is tan theta equal to?
NC by NC.
MC by NC.
Yeah.
Okay, what is MC in this triangle?
No. That's the base. MC by MN.
What is tan theta equal to?
Hold up, ma'am.
Formula, tell me.
I took the hypotenuse. It is
What?
MN by NC. MN by
MN by
NC.
NC. What is the formula of tan theta?
Ma'am, perpendicular by base.
Exactly. So remember this, perpendicular by base. This is
I
the
got
perpendicular.
confused.
How are you taking the hypotenuse? Every time you told me MN by NO, MN by NI. So MN
Yes,
by
ma'am, I got confused.
NC as well. Okay. This will be MN by NC. So we can say tan gamma is almost equal to gamma, which is equal to, we can say tan gamma is almost equal to gamma, that is mn by nc. Okay. So here, if we put in up the formula, like values of alpha, beta and all, we'll get N1 into alpha plus gamma. Alpha plus gamma mn by nc is equal to n2 into gamma minus beta, means mn by nc minus mn by ni. Mn will be cancelled and all.
Yes, ma'am.
Now see, on. What is on? On, it's better if you write this as op. On can be written as op. That's why we took this point.
Yes, ma'am.
And what is op equal to?
OP is equal to U.
Op is equal to the object distance, but we are going to
Yeah.
put it as negative. Object distance is
Okay,
negative.
yeah.
On is equal to op, that
Minus.
is minus u.
Hmm.
Okay. And is there, this is also put, that is minus u. Now NC, look, NC can also be written as PC,
And C can be also written as?
PC,
Yes, ma'am.
which is the radius of curvature. Okay. So we
Hmm.
can say NC is almost written as PC, that is the radius of curvature. So this I have put 1 by R is equal to N2. 1 by NC is also 1 by R. Now Ni can be written as Pi, which is the image difference,
Yes, ma'am.
and I is equal to Pi, which is the image difference. So we put here the values. This is what we get 1 by R, 1 by R minus 1 by V. Clear?
Yes, ma'am.
Now see, these are the values OP and whatever I told you right now, same thing. Okay, OP's value, ON, NI and all. That's why we have used this. Now see, let us just simplify this a little bit. Basically, what we'll do, we'll just first open up the brackets. Open the brackets. Means N1 by minus U plus N1 by R is equal to N2 by R minus N2 by V. Now shift the R and R terms together. So N1 by minus U, this goes here, N2 by V is equal to N2 by R minus N1 by R.
Hmm.
So R can be taken common. So N1 by minus U plus N2 by V is equal to N2 minus N1 divided by R. This is the whole formula. To find a relationship between all the three of them, and you have to put in the sign conventions. Clear?
Yes,
See,
ma'am.
in only optical instruments, you don't have to put any sign convention. Everywhere you need to put in the sign convention. Am I clear till
Okay,
this
ma'am.
derivation?
Yes, ma'am.
So if I change it from denser to rarer, if I take, see what all will be the change. This is denser, N2, this is rarer. This is
Hmm.
alpha, this is angle of incidence. This time, here you will get, because this is a convex surface has been taken. If it is convex has been taken, so look, gamma shifts this side. So in your calculation, see, same derivation you have to do. I'll just give you a hint how to derive. You can derive it later. I plus alpha is equal to gamma. So I is equal to gamma minus alpha. And from
Yes,
this
ma'am.
triangle, if you look, this one, this is for alpha. And for R, if you see, this triangle, these are the opposite sides. Uh, for R, just a second. This is alpha, this is I, this is gamma for this one. Okay, this hasn't been drawn properly. This is the this is the surface. This is the normal. Must be passing through. So this is the normal part. It has been shown. Okay, this is the normal actually. Yeah, I didn't draw the normal here. See, when you just draw, no, draw the normal over this side. So that this
Okay, ma'am.
should be clear from where are we drawing. Are you getting it? Like in
Yes, ma'am.
this one. See,
Hmm.
I was made with this normal. Okay. Now what has happened? This ray, it's like, I'll just tell you. This was I, alpha and gamma were equal to this I. Okay. Now if I just shift this, and I shift it here. So gamma becomes here. Are you getting it? This is how the gamma has
Yes, ma'am.
is here. They two were equal to this. This time, these two are equal to this. Okay. If
Okay, ma'am.
here R plus beta was equal to gamma. And if we look from here, alpha plus gamma was equal to I. Because of the normal that was clear, here the normal has not been drawn. I'll redraw the figure. I think that's better. But same derivation it is. See, here from here, L gamma plus beta, these opposite sides will be equal to this exterior angle. Okay, because see, this is angle of incidence over here. I plus alpha is equal to gamma. Angle of incidence. So object is there. This is the normal. No. Here, no. I'll redraw this figure. This has been written incorrectly. I just, I'll redraw it. Okay. Because see, from here, the angle of incidence will be this. The angle of incidence between the incident ray and this. And then these will be, I'll redraw it. It's just that the MN will be shifted. I'll redraw it because this has some mistake. This way it cannot be
Okay,
done.
ma'am.
I'll tell you this later. What you do, this derivation is clear to you?
Yes, ma'am.
You write down everything from here. Just text
Okay,
done
ma'am.
once completed in the chat box. I'll just offer one heart and pause. Okay.
Okay, ma'am.
All right. Please write.
Ma'am, can you scroll down? Ma'am, can you scroll down? Ma'am, can you scroll down? Ma'am, please hold up. Ma'am, can you scroll up? Done, ma'am.
Just let me just tell you the diagram. Actually, if you know the diagram, the derivation is exactly the same. Same steps you have to apply. Okay.
Okay, ma'am.
So that's why. See, now I've made it properly. Look, the normal version there, no? Now angle of refraction is there. This is your normal, okay? Because
Okay,
the
ma'am.
surface is here, no? This time. Actually, I think
Hmm.
the surface, we have taken a convex surface. This is the normal this time, correct?
Yes, ma'am.
This is the object, and here with this normal, here is your angle of incidence, right? So there is no problem
Yes,
with
ma'am.
that. Here we will
Hmm.
have angle R. See, this is the normal and this is the angle of incidence because incident ray with the normal will give you angle of incidence and the
Yes, ma'am.
refracted ray with the normal will give you angle of refraction. So you can simply say that this is the normal, this is the refracted ray. See? angle of refraction. So same thing, I plus alpha is equal to gamma. Till here, I think I already wrote this is equal to gamma minus alpha. And from this one, gamma plus beta is equal to R. Look,
Okay,
gamma
ma'am.
plus beta is equal to R. So same derivation you'll have to do. This will be the conclusion. N2 by minus U plus N1 by U. Whereas here you were getting N1 by minus U plus N2 by U. So this will be just interesting. Okay. Write it. Let's practice questions.
Okay, ma'am. Done, ma'am.
Okay, see, this says that a sunshine recorder globe of 30 centimeter diameter is made of glass of refractive index 1.5. A ray enters the globe parallel to the axis, means from here sun it is entering, it gets refracted and then it gets refracted again. Final image is formed. Here a temporary intermediate image is formed, that is I dash. It is find the position from the center of the sphere where the ray crosses the axis. This crossing. See, basically here this is a curved part. At this point, this is your rarer, this is your denser. So from rarer to denser, that's what we saw first. Remember, n1 by minus u plus n2 by v is equal to n2 minus n1 by r.
Yes, ma'am.
So this from here, the ray is coming parallel to the ground, means from infinity. So your u will be infinite, correct? Now here,
Yes, ma'am.
you know the refractive index here, your n1 and n2. Okay, one more thing. One more thing. Here you have to remember n1 was a rarer medium. So if you wish, you can replace the whole formula with rarer also, rarer by u, whatever is convenient for you. Okay, so rarer by u
Okay,
also
ma'am.
you can write. So see, this will be n1 will be air, n2 will be 1.5. The radius of curvature, it's already given in the question. It says 30 centimeter is the diameter. So radius of curvature will be 15 centimeter. 15 centimeters. V is missing from here. Now what will V be? V will give you, at this point, if you apply the spherical refracting surface. So from here, it will give you the total image distance from this center of curvature. This intermediate one, because for this point, the image is this, the intermediate one. It won't provide you this one. So you calculate this separation as V dash. Let's say this will give us V dash. And then you calculate, you use the same formula for this from denser to rarer one, from here to here, to calculate this distance. That is your V. And then you subtract to see where it crosses the axis or whatever is asked in the question. Got it?
Okay,
What you
ma'am.
have to calculate?
Yes, ma'am.
Rarer to denser, denser to rarer. Okay. And for denser to rarer, you're going to use the formula n2 by minus u plus n1 by v is equal to n2 minus n1 by r. See here, your n2, this is the denser one. Right? Now see, denser and rarer, if you look here, this was where your glass was put, right? N2 was where the glass was put. That is, denser is the N2, rarer is the N1. So
Okay, ma'am.
N2 will be 1.5, N1 will be 1. Now here the object distance. See, what will be the object distance? Object distance will be this intermediate image is acting as the object. Look, the rays are actually from the intermediate. Can you see?
Yes, ma'am.
This is actually producing the light rays due to which all these things are occurring. So here this will be V dash will be the object. Though you have to put in the sign convention, R will still be the same, that is 15 centimeter. Why am I focusing on centimeter? So that you know your final answer will come in centimeter only. Okay. And now for
Okay,
this,
ma'am.
whatever will be the V will be your final image distance. Got it?
Yes, ma'am.
In fact, here, see, this is giving you the virtual object. This is what is known as the virtual object. That is because it's not a real image that is formed. This is a virtual
Hmm.
image for the first case and a virtual object for the second case. Calculations, I think you'll be able to do.
Yes, ma'am.
Please copy this. Bashmi, are you done?
No, ma'am. 1 second, ma'am.
Just take the screenshot. Actually, I have another class right now. Can you just take the screenshot, please?
Yes, ma'am. Yes, ma'am. I've taken a screenshot.